Hello and welcome to this video I have called Troels' Troll Toll. I have called it a thought experiment, but basically I just want you to consider how you make your client and server and database interact in your semester project. So that's the goal of this video, to make you think a little bit about how you structure and how you approach your project. So that's the goal. Right, we want to think about what data we send and how much and how often we do it, because this client-server connection and the server database connection, these can be considered bottlenecks in your systems, and if you use these connections too often and too much, they will slow down your system. So last semester you probably stored your file in you stored all your data for the system in a file, and in my experience, what I've seen earlier, it was just an array list, and you serialized it all and put it into a file, and whenever you needed to start your system, you would load everything from that file and back into the system. And we want to do something slightly more clever, because that is not scalable. You cannot load your entire database into your system when it grows too large. So we need to think about how we approach this problem, and that's where this video comes in. So in order to explain and introduce the ideas, I have made a little story, you might consider it. So this is a group of islands, and on these islands lives a group of people. These guys here, they make their living by building and selling various stuff, and in my examples here, that stuff is furniture. So there is an island to store all their materials. There is an island to house the people living here, and there are two small islands, one here and this guy, the harbor islands, and then they have each their own harbor with a harbor master. So sometimes a boat or sailor comes by to visit and buy stuff, and that sailor will interact with one of the harbor masters. Right. So I know you're wondering about the trolls, but we'll get back to that in a second. Alright, so obviously this entire setup represents a client-server system, as you might see it in your semester 2 project. This here is my database where we store all the materials, my data. This here represents the server. I have two clients, and each client has a GUI, and the GUI is where we interact. So the sailors that interact with the harbor masters represent the users. Each of these islands here, from the database to the server and from server to clients here, they are connected with a bridge to indicate the client-server connection. And whenever you want to cross the bridge here, you have to pay a troll toll to the trolls down below in the form of cookies. So you cross here, you have to pay cookies to this guy. You cross over here, you have to pay cookies to that guy. And the number of cookies we pay, we pay for each time we want to cross, but we also pay for the number of items we want to take with us across. So basically the more data we want to send from the database to the server, or from the server to the client, the cost is increased. And in my example, it's cookies. In real life, it's time. So the thought experiment here is about how do we minimize the number of cookies we have to pay in our system. Okay, so one day a sailor comes and visits here, and he would like to buy 10 chairs. And now the question is, how should the islanders approach this task? And we're going to look at a few various options. And number one is to first get everything out of the warehouse. So you could consider this identical to your step 1 approach, where you load the entire file. I load everything from the warehouse, I send it to the server and forward that to the client, and then my harbor master here, he will construct the chairs from the materials. There we go. And they are then given to the sailor. Right, so that's one approach. Everything out of the warehouse, send it all to the Harp Island, my client, have the client construct whatever data it is we need, the data objects, and then we show it to the user. That's the idea of option 1. Option 2. Right. So we still get everything out of the warehouse. We send it to the main island, my server, and we construct the chairs on the server side. So all the extra islanders here represents that the server is usually a lot more powerful than your old slow laptops, which are the clients. So the server is a high number of processors with a lot more computational power than your laptop. So we can make the server build our objects here, and then we can send the finished chairs to the harbor master, and we can then hand it over to the sailor, show the objects to the user. So that's option 2. And still everything out of the warehouse. We construct the chairs on the main island, meaning that we make the server do the work of constructing the chairs. That could represent doing some data construction or doing some heavy calculations or something similar. And once that's done, when the actual work is done, we send it to the client here. Option number 3. This time we just get what we actually need out of the warehouse. We send it to the Harp Island, my client. Again, this guy will construct the chairs and give to the sailor. Right, so we have optimized a little bit by not getting everything out of the warehouse, but we're sending it, in this case, everything to the Harp Island, to my client, so we're not utilizing the extra computational power of the server. Right, so that's basically the 4th option. So you can probably guess what's going to happen here. Again, we get just what we need from the warehouse. We send it to the server. We make the server do the construction of the chairs, meaning the heavy calculations, whatever data analysis needs to be done, and we send the finished result to the client and show that to the user here. So that's option 4. Just what we need, send it all to the server, the main island, do the work here, and then send the result to the client. So we have minimized the data going from the database to the server, and we sort of send the same data between the server and the client, whether the chairs are constructed or not, but we are doing the heavy work on the server side, which is probably a lot faster than the client. And sometimes I actually see a 5th version, which I also want to mention here. We get what we need from the warehouse for just one chair. We send it to the main island and they construct the chair. And then we go back to step 1, and again we interact with the warehouse on and over until we have 10 chairs. This is obviously representing a number of calls, often in a for loop, to the database. So there's a lot of network activity going back and forth between the server and the database in this example here. So there are multiple approaches to solving this problem. You will see that all of them ends up with give the chairs to the sailor. So we have actually solved the problem, but not all approaches are equally efficient. So the general best approach is get as little as possible out of the database. The database is super good at filtering and sorting and ordering and joining and selecting attributes or data. So it's a database that's really optimized to working with this data, and you should really try to utilize the database as much as possible. We will then, in our case, for the step 2, we will then make the server do whatever needs to be done, as much as possible at least, of loading and calculation and object construction. And then we send as little as possible to the client, and we also want that to be as finished as possible. So that's basically for your Step 2 project, and it is true for other projects as well. But just to add a little bit confusion, because sometimes it's actually better to make your client do more work. If you consider that you have an open connection, which we have seen in SDJ2 so far, we maintain the socket connection open, so there's a thread running on the server side for each socket connected, in most cases at least. If you want to have 1,000 or 10,000 users connected, then you have 10,000 threads running, and that could kill your server. And in that case, we want to make the server do less and put more work onto each of the clients, so as to not overburden the server. So again, multiple approaches, you might get the same result in the end, but some of them are more efficient than others. So basically, remember the cookies. Think about how much data you send, how often you send it, and what kind of data you send back and forth. Consider the client server and the server database connections a bottleneck in your system, and if you have to use this bottleneck too often, your system will be slower, and that will decrease the user experience. We don't want that. So there's no real best approach. Each case can be done in different ways, and each case may have a different best approach, but at least I want you to think about the various options and possibilities, so you don't just hack away until something works, because that something may not be the best approach. Alright, so that was the first example. I actually have two other examples, so let's take the next one here, just to pique your thought process a little more. So back to the island. I have another guest coming. There he goes. He wants to buy a dinner table set. And again, we can approach this so in various ways. So here we have a couple of chairs and a table that we might be interested in a collective whole. Right, so how do we approach this? We could first construct a chair and send that. And here's the first chair. What do you think about that? And the sailor will say, yeah, okay, that looks good. Let me see the second one. And okay, here's the second chair. What do you think? And we can then fetch the next and a fourth one, and then the table, because now he has looked at each part. And if you just get this data from the database, then maybe he wants to look at another chair, and we have to fetch that from the database again. So here we have to consider the workflow of the user. Can we assume the sailor or the user usually wants to see all 4 chairs on a table as a collected whole? Should we fetch everything in one go and just store stuff temporarily on the harbor island or on my client? So maybe after viewing a chair and then the table, and then he wants to go back to the chair again. So you could consider that a user wants to view some data, maybe a list of data, and then he only wants to see some of the objects, and then he wants to see some other subset of the objects. And instead of getting everything anew from the server, we could just store it in our client-side model as a sort of temporary cache, if we're using the MVVM approach. So the model can be used to store temporary data. If we have a list of students and we want to see students with attendance below 75, we would filter the list but still keep the entire list in the model. And then we want to see the opposite, the students with attendance above 75, and we would then still have the list in the model, so I don't have to pay the troll toll of contacting the server again to get the list once more. But this requires that you analyze the expected workflow of the user, because you can store all kinds of data on this client side, but if the user is not going to use it then, or view it or work with it, then it's just a waste. So a different approach here, again thinking about how much data we send, what do we send, how often do we send it. So maybe as a group in this example. So here we have a what we might call related data, and we consider how we work with this and how we facilitate it in our system. Maybe you send too much, meaning the entire dinner set, and that includes 4 tables and the table, 4 tables, no, just 4 chairs and a table, and the sailor only views 2 of the chairs instead of the 4, and maybe that's okay. Otherwise you might send too little, so you increase the client-server connection workload, and you'll have to evaluate which approach is better in your specific case. So we might consider a longer initial wait if we have to load the entire dinner set, but then you have it on the client side, so it's easier to work with and view one chair and then the other, and there's no lag or waiting between viewing one chair or the other. Or we could just get what the user actually specifically requests, and that means whenever he requests something new, there will be a small wait, and if you have to wait too often, that interrupts your workflow and you get annoyed. So again, there are pros and cons for each approach. For the last example, we have a new sailor visiting. I ran out of boats, so yeah, I have a car, whatever. So this guy, he wants to view he wants to buy a chair, but he's not entirely sure which chair, so he would like to look at the selection of chairs that are available on this island. And the question is then, do we send all our chairs to the harbor master to show to the customer, meaning that we have to construct each of them, the entire chair, and send a large list? We could also just send what we might call a lightweight representation of each chair, a catalog, and that could be, just titles and then perhaps a small picture, and then if the customer wants to view the details of a specific chair, we would then fetch that specific chair from the server side, and only that chair with the extra details. If we consider an example of a list of students, and I'm just interested in some of the students, I would send a list of all their names, and then I would click one of the names, and that would take me perhaps to a new view or just load data into an existing one. So I would send that student ID to the server and request all data related to that specific student and send that back again. So the initial workload is just fetching the list of students, and then the secondary, we might call it, workload is happening whenever I click a student and I have to fetch data for that specific student. Now when you have worked with RMI, that can really facilitate this process here. Each of these chairs could be a remote object. So you just fetch what is necessary, and then when you click one, you have access to getting the real object on the server. So again, different approaches. If it's just 5 chairs, then there may be no reason not to just load everything. If it's thousands of objects and each object is containing a lot of data, then maybe you just want to send a representation of each object, a proxy we might call it. So multiple ways of solving a problem again here, and some of them may be better than others, but there's no strict always better answer. So again, I just want you to think about your approach. Right, so that sort of concludes the video. I want you to think about how much data we send across the network, from the client to the server to the database and back to the server and to the client. I want you to think about how often we send the data across the network. Sometimes data more often is better than a large chunk of data initially, and sometimes the opposite is true. And I want you to think about, where do we do the work? And do we do the work on the client, on the server, or in the database? I often see approaches where, again, for example, a list of students, you want to get students belonging to the second X class. And the approach of the semester project group would be to load the entire table, all students, into the server. And then in the server they would have a for loop where they do the filtering. And that is super efficient because the database can do that. You can order by, or you can sort by, or filter by. I'm not a database expert, but I know you can do that no matter what the keyword is. So the database should definitely do this selection for you, so you don't have to loop through everything in the server side. So to put it very simple, as a rule of thumb, but not always true, that's your approach here. If you can do it in the database, then you should do it in the database. If it otherwise, you cannot do all the work in the database, then you do as much as possible, and then you check, can I do the rest of the work on the server? And if so, then you make the server do it. And finally, if you still have something left that cannot be done in the server or the database, then you will make the client do it. But for the SEP 2, this should be your prioritized approach. So I hope I've sparked a thought about how you approach your semester project, at least. I know it might be a bit of a strange example, but my experience is that the silly examples are those you remember best. So if I come on second semester and I poke you and ask you about Troels' Troels, hopefully you will remember what that's about. We'll see how that goes. So that's all for this video. Thank you for watching.